Let's say this represents my bank account and this represents your bank account. Feeling a little generous, so I decide to donate some money to you. But you're also feeling generous, so you donate the same amount of money back to me. And this is happening at the same time. At equilibrium, this is what it sort of looks like. In that, my bank account, because I donate some money to you and that same amount of money is coming back to me, the amount of the bank account that's in there, it doesn't go up or increase because whatever comes out, it comes right back in. And that goes same for your bank account. That your bank account might have slightly gone up, but then it automatically goes right back down where it is because you're donating back to me at the same time and of the same amount. So it is very similar to chemical equilibrium again, in that at equilibrium, the concentration of the reactant, quote unquote, my bank account, and the product, quote unquote, your bank account, will stay the same at equilibrium. Not only that, the transfer of the money from mine to yours and yours to mine, that rate is exactly the same. And that's how it is at how we know it's at equilibrium. Let's take another example of nitrogen gas and oxygen gas forming together to form a product, forming 2 nitrogen monoxide. Now this is also at equilibrium because now the nitrogen monoxide is also forming back into the reactant and splitting off into 2. The concentration of the reactant at equilibrium does not change, nor does the product concentration change. It doesn't mean that nothing is going on. What it just means is every time we have a reactant forming into a product, the product is forming back into the reactant at the same time at equilibrium. So we can take this equation, chemical equilibrium, N2 plus O2, and you see the double arrow indicating that there is an equilibrium going on, forming 2 nitrogen monoxide. Well, we can grab this, we can come up with what is called the equilibrium constant. Equilibrium constant, also known as Kc, is the relative measure, okay, it's a measure, it's going to have a value of a product over the reactant. So you see the product, the nitrogen monoxide and the nitrogen oxygen gas on the denominator. And it's only at equilibrium, not any other times. If it was any other times other than equilibrium, at other times, you're looking at reaction quotient. And that's represented as QC, and that comes in a different video. Now, right here, we're talking about equilibrium constant. So what is this, all these NO, N2, and O2 really represent? Well, note that the top one here, NO, and it has some bracket. That bracket means that it's the concentration of the nitrogen monoxide in molarity. So this is in molarity. And the constant for these guys, these are also the concentration for the reactant side, so this side. And note that there is a little 2 right here. Where does that come from? That is the power of the coefficient from the balance equation. So that's coming from this 2 here. So here there is a 1 because the coefficient is 1 here, but we don't write it. That's all it is. Now try this learning check. Write the equilibrium constant Kc for the following reaction and come back and check this video. And here is the key. Please note that these are all gases, and if you have a solid or a liquid in here, it would not be part of the equilibrium constant. So say that this SO2 just happens to be a liquid, then we wouldn't include this underneath the equation. It only applies for gas and aqueous.